that we'll be having a shorter class today because of one festival. So it will be a 45-minute class, which should be done by 7:05ish. And what is the bad news? There's no bad news. I was kidding. Okay. So if you guys are aware, there is a festival called Chhath Puja, which is primarily celebrated in states like Bihar and UP. Since I'm from Bihar, we have this festival happening, so we'll have to go somewhere to do some puja. Okay. All right. So we have Anika, Davik, Viswa in the class, and then we have Siddharth here in the classroom with me. Let me do one thing. Let me just send a reminder so that everybody is here. Class has started. All right. So we wanted to start. So far, if you guys remember, we talked about linear equations, system of linear equations, inequalities, and whatnot. Now we want to grow up a little bit more. I mean, I'm already grown up. I want you guys to grow up a little bit more with math. So we're not talking about growing with respect to age. We are talking growing with respect to more maturity, more interesting or intense concepts of math. And that is where we'll start talking about quadratic equations. And some of you would be knowing about quadratic equations, which is good. Some of you might be wanting to do a recap of it. But why we need to kind of deal with quadratic equations one more time, because that is going to become our base for dealing with parabolas. And parabola is just not about drawing a parabola. There are different properties or intricate details of parabola that we'll be able to relate to if we know how to deal with them. Yeah.
You know when we're gonna go over polynomials?
So polynomials are the next thing, obviously. Yeah.
Okay.
Do you have something coming up in polynomials?
Yeah, I have a test.
When?
I think in like a week or 2 weeks.
Okay, so we can go through polynomials in the next class.
Okay.
So again, if you look at polynomials is nothing but an extension of quadratic equations. Because what is a polynomial for me, for all of us? Polynomial. Now let's look at an expression 5x and 2x squared plus 7x, or 5y squared plus 2y minus 9. These are three expressions that you are seeing, and this is called a term. Here you have one term, here you have two terms, here you have three terms, meaning these are the separators which tells you how to count the terms. So when you have an expression with only one term, that is a monomial. When you have more than one term, that is all called polynomial. So when you have two terms, that is called binomial. When you have three terms, that is called trinomial, or everything together. When we have more than one term, that is called polynomial.
Yeah, I have to learn how to like graph it.
How to graph it? Yeah, we will talk about that. So if we get comfortable with parabolas, we are halfway through with graphing of polynomials. It is just going to be an extension of that.
Okay.
All right. So Biswa, Davik, and Anika, are you guys ready to get started, or there's something that you want to call out before I start blabbering? What happened, Anika? Anika is saying, what is going on? So let's first just talk about polynomials. Okay, I'll just take initial 5 minutes to talk about what is a polynomial. What is the basic difference? Why do we call something as a monomial or polynomial? Davik, are you okay? Davik, all good? Yeah. Okay. Well, one more thing I wanted to call out before we start actually. So what's happening is I give you guys assignments after the class. Some of you are sending the assignment, some of you are not. I request each one of you to do the assignment. It's not about you trying to complete it, okay? I want you guys to do the assignments and send it to me. When you are sending it to me, I want you guys to do it like a story, like how I explain things, okay? Meaning, If I have to solve x plus 2y equal to 15, and then I say, okay, x equals 15 minus 2y. I'm stitching the story one after another step. I want you guys to do the assignment the same way, step by step, and then send it to me. Because if I don't get the step by step thing, it gets very difficult for me to figure out what is right, what is not. Some of the parents have reached out to me saying, okay, can you share the answers? And my problem is, I don't really care about the answer. What I care about is how you are doing it. You might miss a step in between that we can fix. Your answer from 5 to 4 is still okay, but if you are not clear about the steps, you have not learned. So I would still not send the answers, but when you guys are doing your assignment, I want everybody to first get to the habit of sending assignments back to me, okay? And when you're doing it, do it step by step, so that I can clearly make out whether you guys have understood it or not. My only goal is to make sure that you guys are understanding things and then doing it. Just saying, okay, question number 1, answer is 15, good. What to do, right? I'm not here to praise you guys for the answers. I'm here to praise you guys for how you're doing it, okay? Can I hear a yes from everybody? Davik, Vishwa and Anika? Okay, that was a silent yes, but that still works. Okay, Anika, how about you, beta? All right, let's move on. Let's move on. So, I have 2x, 5x cubed, 7x to the power 5, 2x minus 9, 5x squared plus 2y plus 17. Okay? All these are expressions. This is one expression. Expression because there is no equal to sign. If I have 2x equal to 15, that becomes an equation. But I had none of them have an equal to sign. So these are all expressions. Yep. There is no outcome. Now, between this guy, this guy, this guy, this guy, this guy, what is the difference we are seeing? This is just one term. This is called one term. When you don't have a separator like a plus or minus, it will be treated as one entity, one thing, one term. So 2x, there is no plus or minus in between. It's one term, only one thing. It's like 2 bananas. X cube is like, let's say, apple, so 5 apples. So x to the power 5 is, let's say, watermelon, so 7 watermelons. Okay? So we are only talking about, these are called one term. These are one term. Unless you have a separator like plus or minus, it will be treated as one term. So this is, these three that you see here, regardless of the power, this is only one term. Expression with one term. Here when you see, you have a separator, minus here. So this is one and this is another one. So there are two terms. Here when you see, you have 2 plus signs. So this is one term, this is another term, this is another term. So you have 3 terms here. So based on the number of terms you have in an expression, they are given different names. And again, a lot of things have come from, when it comes to math, right? A lot of things have come from India and Greece. Okay? So in Greek, mono. Mono stands for one. So all the expressions with only one term, they are called monomial. Monomial expression. Now here you have 2 terms. Like we say, we'll meet bi-weekly, every 2 weeks. So bi stands for 2 basically. So here, when you have 2 terms, it's called binomial. Binomial. So this is meal and binomial. So mono. Mono is 1, bino is 2, binomial expression. And then when you have 3 terms, you can also say trinomial. Trinomial. Yes, Mr.
Isn't that polynomial?
So I'm coming to that. I don't open all my cards in one go. Okay? So mono, monomial, binomial, trinomial, quadrinomial, pentanomial, hexanomial, heptanomial, octanomial, nanonomial, decanomial, whatever. All that blabbering I was doing, that can be grouped together into one term like what Viswa was asking for. That is called polynomial. Okay? So, poly stands for many, mono stands for one. If it is one, it's monomial expression. When it's more than one, it's called polynomial expression. You can be very specific by counting the number of terms, and if you remember, you can use them. But otherwise, in general, we use monomial and polynomial as two broad categories to deal with. Does it answer your question, Vishwa? No, Nanya.
Hi, sorry I'm late.
No worries, beta. Today's class is going to be a very, very short class. And you would know why. Do you?
No.
There is something called Chhat Puja. Yeah? Okay.
I never heard of it.
Okay, no worries. We'll learn about it. Alright, anyway, that's not very important. What I'm saying is, we are just talking about the different types of expressions. If you have an expression with only one term, these are called monomial expressions. If you have an expression with more than one term, those are called polynomial expressions. And any polynomial expression could have two or more terms. Okay? So that's a broad category. So when we'll deal with quadratic equations or quadratic expressions or polynomials, we'll deal with things which have more than one term. That's a broad category. Is that okay to begin with so far? Biswa, Davik, Anika, Nanya, everybody okay? Okay. So this is just the definition part, nothing tricky as a math. So we wanted to start first and talk about quadratic equation today. And what is a quadratic equation? So let's break it down. Quadratic equation, if you are talking about, it relates to something where you have an equation, let's say equal to 15. It talks about an equation. Quadratic equation is an equation. We have equal to sign, so it's an equation. It's an equation where the maximum power to the variable is 2. So if you guys remember, when we were dealing with linear equations, I would have mentioned that, okay, if I'm talking about x plus 15y equal to 17, 2x minus y equal to 22, whatever. These are the equations which are called linear equations because the maximum power to any of the variable that you see x and y is 1. And when you plot them in a coordinate plane, it draws a straight line for us. It draws a line. That's why it's called linear equation. So when you go one level further, meaning one of the variable have a power of 2, that is what makes it qualified to be called a quadratic equation. Yeah? Is that okay so far? Anika, Davik, Katanya, everybody with me? Davik, all okay, beta? You're not saying anything. I hope you're not upset with your teacher so far. Okay. So, we'll talk about how do we deal with quadratic equation and how does it actually help. Let's look at one equation. So, in one of the previous classes, we talked about multiplying polynomials or find out some standard rules for standard formulas like this one, which I'm assuming most of you would remember. I'm not going to prove it again, but we will come back to it if anybody has any doubt. Okay. So these are three standard formulas: a plus b whole square, equals a square plus 2ab plus b square, a minus b whole square equals a square minus 2ab plus b square, a square minus b square equals a plus b times a minus b. Does these formulas, I mean, do these formulas look familiar to you guys, or it's no? Anika is finding it familiar. How about Ananya? So this is about multiplying polynomials, okay? So the polynomials that you are talking about. This is the first step of multiplying polynomials. If you look at this, a plus b whole square, this is nothing but a plus b times a plus b, okay? This is one polynomial and this is one other polynomial. We are multiplying these two polynomials. And how do we do it? Use that spray, okay? If you see anything flying closer to you. Okay? So this is one polynomial a plus b and the other polynomial a plus b. When we try to multiply this, that is what will give me a plus b whole square, right? Like we have x squared is nothing but x times x. Correct? So a plus b whole square is nothing but a plus b times a plus b. So I'm just breaking it down real quick so that no, it doesn't look like a surprise to you guys. A plus b whole square is nothing but a plus b times a plus b, which you can break down further using distributive property. Like 15 into 4 is nothing but 10 into 10 plus 5 into 4. And you will say 4 times 10 plus 4 times 5. Correct? Yeah? Same way here, when you have a plus b times a plus b, what you will do is, you will split them. So this means a times this whole thing plus b times the whole thing. I've distributed this whole thing. You can start from here, you can start from here. Any which way is okay. Yep. Am I going the right pace, or I'm getting you guys more confused? What does that mean? This was saying this. Is it okay or not okay?
I'm confused.
Really confused? Okay. Davik, what is your response? I want to know everybody's response.
I'm a little confused.
You're also a little confused. How about Anika? It's okay. Say it, I'm confused. Okay. And talk to me, beta, okay? Everybody has to talk to me. I'm not here to scare anybody, okay? Talk to me, don't rely on technology too much. So let's go step by step. We are talking about multiplying polynomials, okay? A plus b whole squared, I said this is equal to a squared plus 2ab plus b squared. Everybody can see the board, okay, right? Okay. A minus b whole squared, I said this is equal to a squared minus 2ab plus b squared. And a squared minus b squared, I said is equal to a plus b times a minus b. Okay? So far okay? Now if I say 5 squared, what do I mean? 5 into 5? If I say 8 squared, what do I mean? 8 into 8. If I say x squared, what do I mean? X times x. That is okay? So here, in this case, I am saying a plus b whole squared. That means I am saying a plus b times a plus b. So far okay? Yeah? I am trying to make sure that this formula a plus b whole square equals this, okay? That's what I am trying to do. And in a way to achieve that, we are doing multiplying these two things, a plus b and a plus b. And a plus b, if you look at it standalone, these are polynomials. You are looking at one expression with two terms. This expression also has two terms, more than one term. Yeah? So we are multiplying polynomials. Yes, Biswa?
Do we have to change it, or can we just keep it the first one?
I'm sorry?
We have to change it to a plus b multiplied by a plus b.
Yeah, that's how you'll know, right? I mean, a plus b whole square equals this. How would you know it, right? I mean, we have to just break it down, correct? A plus b whole square is nothing but a plus b times a plus b. Like x square is x into x, a plus b whole square is a plus b times a plus b, correct? Yeah? Okay. So now we are trying to find out whatever I have written here above, is that holding enough water or not? That's what we are trying to ensure. So we said, okay, fine, let's find it out. A plus b whole square is nothing but a plus b times a plus b. Now, when you are multiplying this thing, when you are multiplying polynomials, okay, it also uses the same concept like I was showing you. 10 into 4. What can I do? 10 I can write as 6 plus 4 or 7 plus 3, whatever you like. 7 plus 3. This 10 I replace with 7 plus 3 in the bracket. Now I can break this bracket open and then becomes 4 times 7 plus 4 times 3. Correct? So everything that I have outside, that multiplies with each of the thing inside the bracket. Same way here, if I have a plus b times a plus b, if I treat this as one thing, that means I have to multiply a with this whole thing, and then I have plus b with the whole thing. Correct? And you can choose which one you want to fix. If you want to fix this one, you'll say a times this and b times this. Any which way is okay. Yeah? Now, this is what is called distributive property, meaning when you have two brackets, you have to break open the bracket. This is how you distribute. Is that okay, Davik, so far? Anika, Nanya with me? And nobody is getting forced here to say yes, okay, or give me a thumbs up. I don't get extra money for getting that like. It is a more of a moral boosting thing for me, okay? If you guys say, okay, you are able to follow it, makes me happy. That's it. Okay? Now, so a times this whole thing and plus b times the whole thing. Now let's keep breaking the bracket open. Now a times a, and then it will become a times a plus a times b. Similarly here, when you are breaking this bracket open, it becomes b times a plus into plus, that is plus b times b is this. Yeah? A times a is what? A square. A into b, I can call it ab. Yeah? Similarly, b into a into b or b into a, same thing, right? AB, we can call it AB as well. 4 into 3 versus 3 into 4, both the same thing, right? So I'll call it also AB. And then b times b is nothing but b square. If this is apple, a square is apple, this is b square is banana, this is AB, I'll call it a watermelon or maybe grapes. That's okay. Anything is okay. So this is one fruit, these two are same fruit, and this is a third fruit. So this becomes a squared plus AB plus AB. If AB is a watermelon, one watermelon here, one more watermelon here. That becomes two watermelon. My watermelon is AB. What did we get? A plus B whole square. We split this way. Then we use the distributive property. We are breaking open all the brackets. And what did we get? B square plus 2AB plus B square. Does it make sense now, everybody? So whatever formula I was talking about, a plus b whole square equals a square plus 2ab plus b square, this was not in the thin air. Davik, does that make you a little more comfortable? Okay, Anika, Ananya with me? Sort of makes sense? Okay. I will repeat myself one more time, but not by doing this one. I'll do another one, which is same thing. Yeah? So here, a minus b whole square, same thing. A minus b whole square is nothing but a minus b times a minus b. Yep. That means I can break it saying a times a minus b, and then I have a minus here. Minus b times a minus b. Yeah? Is this okay so far? Anika, Nanya, both of you okay? No, again, I'm calling out names not to put you guys on the spot. I'm just trying to make sure that I'm not rushing through it. Okay? So now, a minus b times a minus b. So a multiplied by the whole thing minus b multiplied by the whole thing. That's how I'm breaking it using distributive property. Now, let's break open all the brackets. A times a. And I have a minus here. So nothing means a plus. Plus into minus gives you a minus. A times B is A into B, or AB, we will put it later. And then again I have a minus B here. Minus nothing means a plus. Minus into plus gives me a minus. B times A, I will call it B into A. And minus into minus becomes plus. And B into B becomes B square. Okay so far? Ananya, David, Vespa, everybody. Anika is getting scared of me now. Okay, before he calls out my name, let me give a thumbs up. I'm just kidding. Alright. So basically, I've done nothing fancy here. What I'm saying is, I'm breaking them down to smaller pieces and then splitting it. This is what we have now. So A into A is nothing but A square minus A into B. I'll call it AB. Minus again B into A or A into B is the same thing, so I'll call it again AB. And then it's a plus B square. What do I have? Apple, banana, watermelon. 2 watermelons, but both are negative. So it becomes 2 negative watermelons. This is the formula I was talking about. So A plus B whole squared is A squared plus 2AB plus B squared. A minus B whole squared is A squared minus 2AB plus B squared, like what you see here. So the difference between A plus B whole squared and A minus B whole squared is only this guy. A squared plus B squared is common. Okay? The only difference being, when you're talking about A plus B whole squared, you have a 2AB plus. When you're talking about A minus B whole squared, you have a 2AB minus. That's the only difference. And that's why, even if I was pretending to be super intelligent and say, see, I memorized the formula, I have only kept one thing in mind, that both are same. When you have plus here, this is plus. When you have minus here, this is minus. That's how I have been able to retain it with me for last 38 years now. Yeah? Are you guys with me so far? Relatable? Now, this one, A square minus B square equal to A plus B times A minus B. So this one, why would I break my head with this? I had these two things, let's multiply them and see what happens. A plus B times A minus B. Let's see what is that. So this becomes, again same thing, we'll break it like A times whole thing plus B times the whole thing. Yep. Okay. Now let's keep breaking them. A into A, this time we'll go a little fast. A times A is nothing but A square. And then I have plus and a minus, that becomes minus. A into B is AB. And here I have plus. So plus B into A. BA or AB, same thing. Plus B and minus B becomes a minus. B into B is B square. So I have a plus AB and I have a minus AB. They will cancel out each other. So that's what becomes A square minus B square. That's what we were talking about. A square plus B square equal to A plus B times A minus B. So we took this one, broke it into smaller pieces, and we found this whole thing is equal to this one. That's what is our third formula. Are you guys with me? 100%. 200%. Alright. Alright. So now you guys will be thinking that why we are breaking our head to deal with these formulas. Trust me, these are the most generic formulas that you will deal with till you are dealing with math. So next year I'll turn 50 and I'm still dealing with it. So I can guarantee you guys that you will deal with these formulas at least till the age of 40. Okay? At least till 40. Now, just to summarize that, A plus B whole square. Anybody remembers it? How much it is?
A times A plus B times A plus B.
No, tell me the final result.
Oh, A squared plus AB 2AB.
Okay.
Plus B squared.
Okay. Now A minus B whole square. Can I get an answer from somebody on the screen? How much is A minus B whole square, if you guys remember? I'm just trying to check. Is it only a problem with me that my memory doesn't support me much, or you guys are also dealing with the same thing? Anybody, just give it a try. Let's see how wrong you go. How much is a minus b whole square? Anika is thinking. Ananya, give it a shot. Give it a try. Go wrong. That's okay. Vishwa, okay, tell me.
Is it a times a minus b and then b times a minus b?
No, that is how you calculate. I'm saying what is the result? What is the formula? I'm more interested in the formula.
The formula is to find the area of something.
No, I'm saying tell me what is the value of this. So like we just now noted down, right? A plus b whole square equal to a square plus 2ab plus b square. I'm just trying to find out how much is the value for a minus b whole square, which we derived just now.
Oh, okay.
Give it a try. Don't be shy. That sounds rhyming. Yep. Okay. Tell me.
A squared minus 2ab plus b squared.
Yep. So this is what I was saying. See, again, I'm just helping you guys to make your mind around these things because these formulas you will use very often. Okay. I'll show you guys also when we start doing it. And how much is a squared minus b squared? Anybody? A plus b whole square, there is a plus, that gives you this formula. A minus b whole square, there is a minus, gives you this formula. When you are taking a mix of these two, that gives you a square minus b square. A plus b times a minus b. Yep. There are three formulas, okay, that will remain as a basic building block when we are dealing with quadratic equations, polynomials, parabolas, whatnot. Okay. Now, let's look at the power of these formulas. Okay. Let's look at why did I even waste 20 or 15 minutes of your precious time, right? Now, if somebody says you have a quadratic equation, x squared plus 4x plus 4 equal to 0. Solve it for x. Who can solve it? Okay, don't solve it. Now, I'm saying that we can solve it. How? Now look at this. I have an x squared 4x plus 4. Let's see. I'll keep x squared as x squared. 4 is 4 a square of something? It's 2 square, right? And then this 4x. So see, if I compare this with this formula, I have a square, I have a square, I need a 2ab of this. Now this 4x, I can break into 2 into x into 2. Yeah? 2 times 2 is 4x. Yes, Vishwa.
But why do we break it down?
I am trying to do some magic here. We were trying to solve this for x, right? We were trying to find out what are the possible values of x. Okay? So that was a dad joke, okay? I hope I'm not offending you, okay? No? Okay. So here, we are trying to solve this quadratic equation and find out what are the possible values of x. Whenever you're dealing with the equation, what is your goal? You're trying to find out the value of the variables or the unknowns, right? So here we have a quadratic equation. We are trying to solve it and find out from this equation what are the possible values of x. So what did we do? We looked at this equation, it had 3 terms. I'm trying to see if this equation is mapping to any of these formulas that we have memorized or learned. And by looking at this one, what do I see? X squared, a squared, 4 is nothing but a b squared, 2 squared. This 2ab, 2 into a, here my a is x and b is my 2. So 2 into x into 2. Oh, wonderful. I have x plus 2 whole square written in the form of the quadratic equation. I can say this is x plus 2 whole square. That is how I was able to map it to this formula. I'll give you guys a little bit of time to digest this. I had to solve this quadratic equation and I'm trying to map it with one of the formulas that we have. all the terms are positive here, this could be my best bet. And I'm trying to see if this is mapping to this formula or not. I have x squared, a squared. I have 4, which is 2 squared, so that is my b equivalent to b squared. And then I have 2ab. 2a is my x here, and b is my 2 here. So 2 into x into 2. 2 into x into 2, that is what is my 4x given here already. So I can convert this equation into this form. And what this means? That means x plus 2 into x plus 2 equals 0. Why it would be 0? That will be because either this is 0 or this is 0, right? Then only it can become 0, right? If you are multiplying two things, let's say I am multiplying 5 into 4, will that be 0? It cannot be, right? 5 into 4 is 20. So for us to get a result of 0, one of the two has to be 0. Yeah?
Can't you just factor it or do quadratic formula?
I'm sorry?
Can't you just factor it or do quadratic formula to get the same thing?
So we can do that. We'll come back to that. So that's, see, there are 3 methods that you can use for solving a quadratic equation. One is this, by aligning it with one of this one. Second is called by mapping it to standard form of the quadratic equation, a square plus bx plus c, where you multiply the a and c. We'll come to that, okay? And the third method is when you end up memorizing a formula called quadratic formula, and that formula says if you have a quadratic equation, that will be equal to minus b plus minus b square minus 4ac by 2a, okay? By mapping it to the standard form of the quadratic equation ax plus bx, x square plus bx plus c equals 0. And I'm not going to that third step, okay? This is my third step. When I have no solution, this becomes my magic wand for solving it. But would you apply this formula all the time? No. There are 3 different methods, okay? Yeah?
Yeah.
So let's not get stressed out by the quadratic formula right now. This is my third stage of learning. Right now we are in the first stage. Okay? So what did we do? From this one, we tried mapping it with one of those standard formulas that we learned about. And we found that this can be rewritten in the form of this. That means this equal to, that means this into this. And both are same. That means the only possibility of getting a 0 is if this is 0. That means x plus 2 has to be 0 because both are same. 0 to 0 will get me a 0. Both are same, right? So this has to be 0. That means x will be equal to 2 will go other side. It becomes 0 minus 2, which is minus 2. So from this we found what is the value of x. From this quadratic equation we could find out what is the solution for x. What is the possible value of x. Does it make sense to everybody or it doesn't? Little bit, 20%. Okay, maybe. Let me solve one more problem right in front of you guys, and then probably you will appreciate. I will do everything possible to get your appreciation. Let me do it. Let's say I have x squared plus 16x plus 64 equal to 0. X squared plus 16x plus 64 equal to 0. I am trying to solve it without using the quadratic formula. Now, I mean, see, that you already know, so that is wonderful, okay? I am just expanding your possible options for solution, okay? Now when you look at 64, this is nothing but a square of 8. Yep. Now I can map it to this one and see if this can be rewritten in this form or not. I have a x squared, which is a squared. I have a b squared, which is 8 squared. 2ab. I need this to be. I need to check whether this is in the 2ab form or not. 16 I can write as 2 into 8, correct? And then I have an x. If my x is a and if my 8 is a b, I have a squared plus b squared plus 2ab. Yeah? Yeah? So this is a squared and this is my b squared, 2ab. Oh, this is x plus 8. A plus b whole square form. Correct? Because I have a squared plus b squared. This is my a squared. This is my b squared. And this is 2ab. So this is nothing but a plus b whole square. X is by 8. 8 is by b. So this is x plus 8 whole square. That means x plus 8 into x plus 8 is equal to 0. So either this is 0 or this is 0. Both are same. So that means x plus 8 is equal to 0. That means x equal to minus 8. So here the catch is this. When we learned about the quadratic formula, obviously you will see that you have a magic wand. Certainly agree to that. But calculating the quadratic formula will still take you a little bit of time. If you get very comfortable with these formulas, by looking at this equation itself, you will figure, okay, this is a plus b whole square, x plus 8 whole square. So when you get very familiar with this one, in one jump, you will say this is nothing but x plus 8 whole square. That means x plus 8 equal to 0. That is x equal to minus 8. In less than 10 seconds, you will be able to say that. But by applying quadratic formula, you might take maybe 20 seconds. So when you have more options to choose from, you will always make that call or take that call judiciously to see which one helps you save time. That's the whole purpose. So I'm not denying which way is right, which way is wrong. What I'm saying is, you keep all the weapons in your armory and decide at run time which weapon you would use to save maximum time during the exam. Does it make sense?
Wait, so can you only use this method if C is a square?
Yes. So when we go to second and third method, right, that is when I will tell you guys, okay, how do you make that call? You look at, okay, let's say if I change this to 62, your third term is not a perfect square. You will rule out this option and then you look at the other two options you have. Okay? So that is what we'll talk about in the coming class. Not today. But just to summarize what we did today, we talked about how do we deal with distributive property to look at these three formulas, how these are derived. And this has become the Bible for us. Because if you're dealing with quadratic equation, this has to be a building block. I cannot build a house without a brick. This is my brick. Okay? And then we just saw how do you relate to these formulas to solve a quadratic equation if you see a perfect square or see a possibility of mapping it. In the coming class, we'll talk about other two methods, and they are the only three methods. If you master these three methods, during the exam, when you're solving a problem, when you practice enough, you will see that it hardly takes you 2 seconds to figure out which option you're going to choose. And then, if your path is clearly defined, you will not waste a lot of time for solving it. So that's why, if you know one way, I'm adding a little more weapon into your armory, right? That's what you call it? Yeah. So I'm just adding a little more weapons so that you become a better soldier to fight with any kind of test that you'll come across. Yeah? Is everybody okay with my speech so far? Okay. So I'll give you guys some time back because today there's a reason. And we'll meet again. I'll send you guys some assignments, some problems, right, relating to these formulas. We saw this formula, but you can keep these two formulas also in mind. And now I have started insisting, I mean, not in a forceful way, in a more cordial way, that when I upload the video of the class, I request you guys to watch the video and do a revision of what we have done. You can skip the part where I'm blabbering, giving you unnecessary speech, but wherever I'm doing anything mathematical in nature, just watch it for revising, and then you can attempt the assignments. It will make it much easier. Okay. So far, it was optional, but if you practice watching the video and then try doing the assignments, it will make it much more easier, much more organized for you guys. With that being said, I'll let you guys go, have more fun, and talk to you guys next class. Alright?
Bye, sir.
Bye, 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 everybody.